Hello everyone, welcome to SchoolQuizz. So this side Anjali Singh, and today we are going to start question number 6. Already we completed the up to question number 5th from the NCRT question. So to start the question number 6, I'll share the screen where we'll get the questions. Okay, dear. So you can see, yeah, again I'm going to click there. Yeah, here this is the question number 5th. So in the question number 6 here, from the figure, the same figure you have to see this figure. From this figure, first you have to find which of these three is traveling the fastest. So the figure is like this, which is shown by the graph. So yeah, you can see this side means in the x-axis time, in the y-axis distance. Okay, in the y-axis distance. And now here you can see the time is 0.4 hour, 0.8, 1.2 and 1.6, and the distance is like 4, 5, 6.5 kilometer. It means here the distance is drawn in the graph. Okay, so you can see, are you able to find in these three graphs A, B and C, which is going to be the fastest? Okay, which will be the fastest object? So if I am going to verify it, graph A, B, and C, or you can say the slope of graph, slope A, B, as well as C. Now I think, you can see this slope B is the fastest. Okay, the slope B is the fastest and it has the maximum speed. You can see it acquires maximum speed in the very small interval of time. If you are going to compare this slope B with the A and C, so they are taking more time to acquire the speed. But when you'll talk about the B, this B is taking less time to acquire the more speed. Okay, clear? So yeah, you can see the answer also. The object B has the maximum speed. In other words, the object B is traveling the fastest, because from the graph you can observe this B is acquiring the fastest speed. Okay, if you are going to compare here also, there also, at every point this B is acquiring maximum speed. Okay, now the second is, are all three ever at the same point on the road? All three, A, B, and C, are they intersecting at any point? The question meaning is that, are they intersecting at any point in the graph? So this is A, B and C. Now at point F, if we will see, so there you can see these two graphs is only intersecting. I think the first is B and the another is A. No, C. B and C is intersecting at point F, and at point D, I think this B is intersecting as well as this A is intersecting. And at this point, this A as well as C is intersecting. Okay, so I think no point is there where A, B and C all are intersecting. Okay, clear? Now, the third question, how far has C traveled when B passes A? Okay, so at the intersection point of A and B, the question meaning is that at the intersection point of A and B, how much C is travel? The meaning is that. Okay, so let's find where A and B are intersecting. I think this A and B are intersecting. Yeah, this A and B are intersecting where? Yeah, it's intersecting at point E. Okay, they are intersecting at point D. Sorry. Yeah, this at this point A as well as, yeah, this B. So at the point D, how much C traveled, how much object C traveled. So let's calculate. So here we'll make a graph. So how much it is traveled at point D, at that will be compared, yes. Then the C is at point E. So where at point D, where the A and B is traveled, the C is at point E only. Okay, the C acquire the point that is E. And at point E, the C travels up to 6.5 kilometer. Clear? At point E, the C travels 6.5 kilometer. Clear? Now, how far has B traveled when by the time when it passes the C? Or again, how much the distance traveled by the B? So let's see again, where A and C intersecting, how much the distance traveled by the B. Now let's see. I think this is the point F. Okay, so the distance graph of B and C meet at point F. Okay, so when we'll find at point F, that is 5 kilometer, means the B travel up to 5 kilometer when this B and C intersect. Okay, okay. Okay, when this B and C intersect at point where B and C intersect, there the B travels up to 5 kilometer. Okay, by mistake I said A and C. No, there where B and C intersect, how much the distance traveled by the B. So that is 5 kilometer. Okay, students. Now the next is, yeah, question number 7. So when you'll see the question number 7, in the question number 7, a ball is gently dropped from a height of 20 kilometer if its distance increases uniformly at the rate of, okay, yeah, increases uniformly at the rate of 10 meter per second square. So first I'll tell you, a ball is actually dropped from a height. So this is the ball and it is dropped from a height. So at the highest point, this this velocity is 0 at the highest point because it is at stationary position. Okay, when it is dropped and reach the ground, so what will be the velocity? So definitely u is 0, initial velocity. I think you got the point. And now they are asking about how much the final velocity, means v, if its velocity increases uniformly at the rate of 10 meter per second square. Okay, so 10 meter per second square means that is acceleration. What is it? That is acceleration. Clear? Now what will, yeah, we have u, we have we have a, and yeah, the distance traveled means the ball is from the height, that is 20 meter, means the distance traveled by the ball, that is 20 meter. So we have u, we have a, we have s. So what we have to find? We have to find the v. So let's start. First is v is equals to, from the third equation of motion, that is v square is equals to u square plus 2as. Clear? And we have the value u as 0. Okay, so v square is equals to 0 plus 2 into 10 into 20. You know, we have 2. 2 is in the equation. A is the acceleration. This value is 10, as well as C, the value is 20. So first, simplify it, means multiplication, then, and you know the square is going to another side, that is converted into root. So V is equals to 20 meter per second. And now at the last, oh, sorry, one more question is there. After what time will it strike the ground? So what time? About the time, I'll use this annotate. So at what time? So at what time means what we have to find? We have to find here T. Clear? So we have two formulas. First equation of motion, which is used already. So I'm not going to explain you. We have second equation also. In that also, t is there. So here u is 0, initial velocity. So this value will be whole 0. Now s is equals to half a. This a is what? 10. And t is what? What? Yeah, t we have to find. Okay. And s is, sorry. Uh, yeah, I'll use this eraser. This, okay. So this s is what? 20. So this will be 40 is equals to 10 into t square. So t square is equals to 40 by 10. That will be 4. Okay. So t is equals to 2 seconds. Yes, here also you got 2 seconds. Here also you have 2 seconds. It means you can find the value from any equation, but the specific the value of equation is there. Like from the third equation of motion, you are not able to find the value of t. Why? Because in the third equation of motion, t is not available. Clear? Now, in the second, from the second equation of motion and from the first equation of motion, you can find. Clear? Now, okay, I think, let's see question number 8. Okay, I'll stop sharing. First, I'm going to erase it so that in the next slide, you will not face any problem. Okay, now yes. So please avoid background noises. Now, yeah, up to 7th, I think 9 or 10 questions are given. I think 9 questions are given. Okay, so question number 8. Oh, it's too lengthy. Yeah. Oh, 10 questions are there. It's too lengthy. So we'll cover it in the next slide, in the next class. Okay. So student, till that, stay healthy and stay safe. Goodbye.